Okay, so for this project, you have to cut out, well, okay, for the open box problem, I can do the closed box one next. You have to cut out 4 corners because it has to look like this, and you have to fold up these to make an open box. It's gonna look kind of like a tray or something like that. And these lengths have to be equal, so that has to be equal to that, because in order for those to line up to make a box, they have to. That's going to be the height. It's going to be the height you use. So we can call that length x. That's what you're trying to find to maximize the volume of the box. So that's x all around. So the volume, to find a formula, the volume is length times width times height for volume. Your length, so right now the sheet you're using is 11 inches across on the bottom. And since you're cutting out this much into it, it's basically 11 minus 2 x's. So 11 minus 2x. That's going to be this length, because if you look, it's 11 minus 2x, because when you fold these up, it's going to be the length, this length of the box is going to be that, 11 minus 2x. That was always like something tricky with these box problems. Well, at least I thought. Same thing over here, same deal, you're gonna have this whole length minus 1x, 2x. So this whole length is 8.5. So 8.5 minus 2x. 8.5 minus 2x, that's the width. The height, so you figured out the width and the length. Length, width, the height is going to be this, which is x. That's how much you're cutting. So the height is always just going to be x all around, because you're cutting out the same length from each corner. So the height is x. So now we can substitute these values in that we know for the volume equation. So length 11 minus 2x, width 8.5 minus 2x, height is x.